People are joining, so let's wait for more 2-3 minutes, then we shall start. Okay. So, hello everyone, welcome again. Myself Ahad Shaikh, and I will be conducting today's session, which is motor to wheels or drivetrain for Electric-Chhota Hathi. So, meanwhile, I present my screen. I want like to have more. I would like to tell you something about this session. So, first of all, I would like to make today's session more interactive with you guys so that it shouldn't feel like it's just one way communication. You can give your inputs and your thoughts about in between if you have any kind of doubt or something. And it will be mostly calculation based. So, hope you guys answer the questions in between so that we get good results. And before starting the session, just have a quick activity. So this session is named as. Let me just present my screen firstly. Is my screen visible?
Yes, sir.
I hope it's visible. Yes. Just give me a second. Yes. So I hope you guys see today's session. So the activity I was talking about, as we will be talking about Tata Ace, electric Tata Ace basically. So, and if you are aware of that, Tata, while marketing this vehicle, they have used the term as Chhota Hathi. So, just quickly, can you guys mention in your regional language what Chhota Hathi is called as? Just to give a little start, interactive start to today's session. You can write in comment box, and everyone will else know how it's called as mini elephant. Yes, sure. I suppose there might be people from South India as well and North India as well. uh, Chinnai Yannai in Tamil. That's good to know. Yes. So, am I in presentation mode? I
Yes,
suppose
yes,
no. Is it now in presentation mode?
yes, yes. We can see the copy.
Okay. Okay. Yes. So let's move ahead and see what exactly we will be seeing in today's session. So first of all, we will be having a quick recap to previous sessions that what we have learned. Then we will take one vehicle model which is to be retrofitted, which is a Tata Ace. Okay. Then we will calculate various road loads and tractive efforts using, if you have MS Excel, you can use that. I will be doing on Google Sheet. And we will calculate motor power requirements, battery parameters, and transmission parameters. Okay. So, firstly, having a recap of previous session. So, if you guys remember, in the last session, I have conducted two sessions previously. So, firstly, we talked about retrofitting of any vehicle. So, that retrofitting is something when we remove all the components which are related to IC engine and we make it electric. So we insert motor, controller, battery pack, and all such things. So this is how we make an electric vehicle from the existing vehicle. Then in the next session we talked about various transmission system and the drivetrain of of a vehicle, what all different type of transmission systems are there and all such things. So today we will be talking about how, like, if we are taking any model to get retrofitted, so how we can calculate all the parameters which electric vehicle needs, like motor sizing is there, battery sizing is there, what transmission ratio should we use. So those kind of things we will see in today's session. Just moving ahead, let us do one more small activity, which is called as a brain writing. Okay, so I am giving you one word. That word is, I am just mentioning here. So that word would be automobile. So after seeing this word, let me know what exactly. Okay. So let me know what you guys will, what comes in your mind, and you just have to note down that whatever comes in your mind, and I will ask that. Okay. So I have given you word and automobile. So whatever comes in your mind when you hear word automobile, you can just mention in the chat box, and just in 30-40 seconds, we will discuss. Okay. Hitesh is saying bike. Or you can unmute yourself or tell anything that comes in your mind. Bobby is saying a machine which is used for land transportation. Yes. Quickly, guys, quickly do it. I want to take this session further. So I'm looking for what exactly I want to talk about. Do you guys get it or not? Electric vehicles. Great. I am seeing there are around 54 and like more than 55, 56 people, and there are very few responses. Faster way to reach places. Okay. Okay. Just I will give one few hints. Like you can talk about various segments of automobiles. Okay, sure. What I was thinking is if someone of you have came up with the different segments of automobiles. So, like there are different segments in automobile industry. Two-wheeler is one segment, three-wheeler, four-wheeler, heavy vehicles, and then mining vehicles, special purpose vehicles. So there are multiple segments in automobile domain, and as we are moving further with electrification of automotives, so it's not like just passenger cars or two wheelers, three wheelers has to be electrified. There are other segments as well which needs to get electrified, right? Like there are light commercial vehicle sector is there, heavy commercial vehicle sector is there. So those are also contributing towards the pollution in the environment. We also have to tackle those pollutions as well. So that's why we need to make those segments of automobile electrified as well. Okay. So moving ahead, why we are talking about Tata Ace here today. So Tata Ace is India's best-selling light commercial vehicle of all times. Okay, so it's been there in like since beginning around 1990s, and there are most of the light commercial vehicle segment covers the Tata Ace only. So there are many numbers of Tata Ace running on road, and as they get older, definitely they pollute the environment. And like there are diesel as well as petrol versions, then CNG versions are also there. But if what if we convert all those Tata Ace out there running on the road into electric, so we will have a good percentage of on-road vehicle converted into an electric vehicle rather than buying a new or costly electric vehicle, right? So that's why we can get it electrified. So that's why like there are multiple startups also who are working towards electrifying the light commercial vehicle segments. So there are multiple models of Tata Ace based on the various payload capacities and different engine specs size based on application. Anyone can have owners might have based on their requirements what they have exactly. So let us connect to the previous session that we had on retrofitting. So as we talked about as we are talking about retrofitting of Tata Ace, what steps we can take to make it electric. So firstly, we have to see what are the current specs. Okay, so current performance and current specs, we have to see how what is the maximum speed of current vehicle, then what maximum torque it provides, that what is the maximum engine power that it delivers. So that thing we need to see first. And when we are if we are electrifying it, we need to have it. We need to we will have some expectation from electric vehicle, like from electric version of it. So that also we need to list down what exactly the range we required, right? Because light commercial vehicle segment is something last mile delivery vehicle, which does not travel very long route. It just travels within the city. So if we take a wide range, or we can take a very long range, so definitely it will increase the battery capacity if you want long range, exactly. And or if there is a large battery installed, definitely the charging time will also be there, which will take a lot time to charge. So considering what exactly is the requirement, we have to decide a certain range. And mileage, or we can say kilometer per hour consumption, sorry, kilowatt hour per kilometer consumption, that we have to see for electric vehicle. Then maximum speed what we want. So for light commercial vehicle segment, from our government norms, it's 80 kilometers per hour. It should be limited to that. So that thing also we need to consider. And what maximum torque we want to have it lifting that payload that we are putting in. So these many things we have to list down initially. Then we have to select the architecture where we will install the motor, how what will be the orientation of motor, whether it will be a front wheel drive or the rear wheel drive. So that kind of thing we need to consider. So like here are two models which are retrofitted from two companies, or we can say startups. So one has put motor over here, and they have a conventional propeller shaft which drives the vehicle. So this is the front engine rear wheel drive kind of architecture. And another startup, they put the motor over here only with the rear axle itself. So it's a rear engine rear wheel drive, rear motor rear wheel drive kind of architecture. So that also we need to think which architecture would we can prefer. And then we have to perform the component sizing. Component sizing is something what we have to find the parameters of uh, each component that we will be using. So
Hello,
for
hello, sir. Sir,
yes,
sorry for the interrupting, but sir, your screen is not moving. Like we are in the third slide only.
You are mute.
Hello, hello.
You are mute. Mr. Ahad, you are mute.
Yeah, hello sir, you're on mute.
am I audible now?
Yes, yes.
Okay, so where did I left actually?
Yeah, slide third.
So are you able to see the next slide, fourth slide now?
Yes, yes.
Sir, yes, sir, we can. Yes, sir, we can.
So let me come to the presentation mode. Is it visible now?
Yes.
So am I in presentation mode only, or it's
Yeah, we can see your screen, the slides, but not on full mode.
okay? Give me a is it visible now?
Yes, sir, yes.
I'm really sorry for that.
Yes, sir.
Yes. So I guess there are not much thing to talk about on this slide, and I guess you have heard what I told. I suppose I was not on mute. Okay, sure. So let's move ahead. We talked about what are the why we are going for electrification of Tata Ace, and we were talking about various steps for retrofitting. Okay, and we were at component sizing. So component sizing is something that we need to find the parameters of the components that we are installing in a vehicle. So like there are two major components, which is battery pack and a motor. So these are the major components in electric vehicles. So we have to finalize these components, then only we can decide the other components. Okay, then comes the practical aspect of it, removal of all the IC engine related components, then see what our available space are, where we can install various components like battery, motor, hardware, software, all such thing, and then comes the testing part. So these are the steps of retrofitting. So moving ahead, as you can see, as I mentioned, some of the companies have already made retrofitted models, right? So this is from the Altair Green, which is a Bangalore-based startup, and they have completely electrified Tata Ace model, and you can see they have installed a battery pack over here. Then there is a controller over here. Then motor has also been installed as a on the axle, so it can be called as a e-axle, electric axle, where motor is directly connected to rear axle. So this is how by their idea and by their calculation they have retrofitted Tata Ace. And there is another startup which is called Northway Motorsport, which is based in Pune. So they have also electrified Tata Ace. As you can see, after making it electric, this is what they exactly achieved. So they achieved 75 kilometers per hour of top speed, which gives 80 kilometers of range. Then they have also it's equipped with 5-speed automatic transmission as in conventional vehicle. So like in typical electric vehicle there is no multi-speed transmission, but they have kept it as conventional vehicle. Then maximum torque that motor delivers is 100 newton meter, and battery capacity, gross vehicle weight is there. So this is how they have retrofitted it, and this is what the output parameters they came up with, or the final specifications they have. And apart from Altai Green and Northway Motorsports, there are multiple startups who are working in this domain. Like there is a Atrio and Cell Propulsion. So these startups, they are gaining very much popularity out there, because light commercial vehicle is a big share in automobile market. So making it electric will definitely put a good impact on or the adoption of electric vehicle. So that's why retrofitting can be considered as a good step for electrification of the society. So moving ahead, what exactly parameters we can conclude from here? So we have to see what are current specs. So from Tata Ace website, you can see that what all parameters what are specification Tata is available in. Then what we are expecting it to be, that we have to see, and architecture we can decide. So for motor sizing or drivetrain sizing, we can say there are two methods at a very basic level we can consider initially, which is quasi-static method and engine comparison method. So quasi-static method is something you go from wheel to the from wheel to the engine, or we can say main driver, which is in terms of electric vehicle it's motor, and in terms of ICs it's engine. So what approach you follow is you see what are exactly coming on the wheel side. So wheel side, it various loads acts. Okay, so that loads you calculate, and based on those loads which are acting on the vehicle, you find out what size of motor or engine I should use. So this is the quasi-static method. So going in detail, firstly we calculate wheel parameters at the wheel. So at wheel, what is that? There is a torque and the speed, and that we calculate. And after that, through axle we come to the transmission. So transmission is there is a differential as well and gearbox as well, so that we have to calculate. And torque converter is in terms of automatic transmission, but we can skip that part here. And after transmission there is engine or motor connected, and then comes the fuel, which is battery in terms of electric vehicle. So when we follow this approach, it's called quasi-static method. And there is another method which is called engine comparison method, so which is kind of easy, or we can compare easily. So whatever engine is put in a vehicle, we can have a equivalent size of motor to be installed in order to get the same power, same torque and rpm rating. So that approach can also be followed. So we will be performing today quasi-static method. Okay. So what is quasi-static method? What it does is firstly we calculate vehicle loads. Okay. So vehicle loads has to be calculated initially, and before vehicle loads we provide drive cycle. Okay, so what exactly is a drive cycle? So drive cycle is nothing but a graph of velocity versus time. Okay, so time versus, it's just a time versus velocity graph. Here you will see a time, and sorry, here you will have a velocity on y-axis and you will have a time on x-axis. So at particular given time instant, what is the velocity of the vehicle? So that makes the drive cycle. So there are certain standard drive cycles. Okay, there is FTP, WLTP, or NEDC, MIDC. So MIDC is Indian Standard Drive Cycle, which is used. So here is a FTP 75 drive cycle. You can see here is a velocity speed meter per second, sorry, miles per hours, and here it's time. So this simulation is for around 1900 seconds. So at each instant of time, what is the velocity of the vehicle, that has been calculated, and it can be used to calculate the various forces acting on vehicle. Okay, so what exactly are the forces which acts on vehicle? Is firstly is a rolling resistance. Okay, so there are two terms in rolling resistance. So may I know if any one of you have any idea what are these two terms?
Coefficient of rolling resistance and gross.
Yes, exactly, correct. So gross vehicle weight is a sum of two components actually. It's a curb weight of the vehicle and the payload. Okay, curb weight and the payload. So when we combine curb weight, like curb weight is when vehicle is completely empty, there is no load on it, or no passenger is sitting, fuel tank is empty, and no extra luggage is put on a vehicle. So that is a curb weight. And payload is when you equip the vehicle with, you load the vehicle with all the possible loads that can be there, that vehicle is designed to take. So that thing is there. And this is a coefficient of rolling resistance. So coefficient of rolling resistance is something like when tire patch is in contact with road surface, so the friction force is there, so that has to be calculated. So that's why that's how coefficient of rolling resistance plays the role in resisting the vehicle from moving. So that force has to be calculated. Then there comes the gradient force. Okay, so gradient force is what, when vehicle is moving, like this is the road which is inclined at angle phi. Okay, and there is a vehicle. So when it I am sorry for the very bad drawing. So when it tries to move along up the hill, so it has it weight acts downwards, and it will have two components, right? One will pull it downwards, and one will be perpendicular to the road surface. So which component is going to oppose the vehicle moving further is this component, which is a sine component. So weight of the vehicle into the sine component, so that gives the gradient resistance. And that has to be calculated. And sometimes in vehicle specification you can see gradient percentage. So gradient is given in terms of percentage as well. So how it is calculated in terms of percentages? So what maximum gradient is considered as a 45 degree. Okay, so 45 degree is considered to be 100% gradient. And if vehicle can climb 30% gradient, So accordingly, percentage is calculated. So 30 upon 45 into 100. So this is how the percentage gradient is calculated. Then there comes the aerodynamic drag, or we can say, yes, aerodynamic drag. So what happens when vehicle moves further, the wind which is coming from front and side, so that resist the vehicle from moving ahead, so that has to be calculated, and it depends on various factors like rho is a density of air. So if more dense the air, more will be the drag force. Then a frontal area, so more the frontal area, more will be the drag force. So as you see, the in older cars it has to be like this kind of structure, sharp edges were there, but in modern vehicles it has they have make it inclined in the windshield. So this is how the effective frontal area reduces, and we this is how we reduce the total gradient force, sorry, total aerodynamic force. Then we have to calculate the coefficient of aerodynamic drag, which is practically calculated. Then it is directly proportional to the velocity of the square. So like we see, it's proportional to the square of the velocity. When if there is a small change in velocity, there will be a great change in aerodynamic drag, right? So when aerodynamic drag plays very like when vehicle is at very low speed, it's not that significant to be considered, but when vehicle crosses around 70-80 kilometer hour per speed, then it takes a major part in resisting the vehicle. So this is how aerodynamic for drag force is calculated. Then comes the acceleration force. Okay, so what acceleration force is? It's simple: mass into acceleration. F is equal to ma, as we have already learned in our colleges. So F is equal to m into a. The mass is gross vehicle mass of the vehicle, and acceleration, which like vehicle if starting from zero, so whatever velocity it's reaching, that we can calculate. From there we can calculate acceleration, and it can be multiplied with mass to get the acceleration force. So these many force has to be calculated in order to find the total loads on the vehicle. Okay, and when we find all the forces, we have to sum all the forces up, and like there is aerodynamic force, rolling force, gradient force, and acceleration force. When we add all the forces at each instant, we get the total tractive force which is required to run a vehicle at that particular speed. And when there is a total tractive force, if we have calculated that, based on that we can calculate the torque available at the wheel, which is required at the wheel. Sorry, not available, we are moving from road loads to motor side, or the driving sorry, main propulsion side. So we have to say that it's required at the wheel, not available at the wheel. So this will give the required torque at the wheel. And like how the torque will be calculated, so like torque is nothing but the force into perpendicular distance, right? So if this is some circular shape, and this is a road, and this is a wheel, if we consider, so we require for this total tractive force will be acting over here. Okay, and there is this radius, sorry, total tractive force will be acting over here at the road surface, and this is the radius. So we have to calculate this force into the radius of the wheel. So this is how we will get a wheel torque. And we also have to find maximum speed of the wheel when vehicle is at its peak speed or maximum speed, so that we can calculate with the help of this formula. So wheel speed, so we can say from our rotational motion chapter, we learned that V is equal to R into omega, right? And omega is nothing but, take R as it is, and omega is 2 pi and 2 pi n by 60, right? So this is the omega, and we have to find this n, which is the wheel speed. So we will shift all these component parameters over here. So it will give us V into 60 upon R into 2 pi. So this is what it's written: V into 60 upon R, which is the wheel radius, into 2 pi. So if we have wheel radius and if we have velocity of the vehicle at particular instant, so we can find out at what RPM the wheel is rotating. So that's how we can calculate that. So let's get to the Excel sheet so that we can find out these forces based on the formulas. Let me know. I guess I have to share my screen again. Just give me a. Hmm. Is my screen visible?
Yes, sir.
Okay, sure. So what I don't think we in a short time we'll be able to calculate all the things, but whatever we can cover, I will try to do as maximum. And if we have left something, so like there is a time limit, so based on that we will find out various parameters as of now, and if we are not able to find other parameters, we will continue it in the next session. Okay, so I guess I have to present my entire screen because I have to switch back to the presentation as well in between to show you the formulas. Mm, yes, I hope my screen is visible. Yes. So what I have, like this is a Google spreadsheet.
எனக்கு ஸ்கியூஸ் மட்டும் எடுத்துக்கிறீங்களா?
Excuse me.
ஷோ சார்.
Excuse me. Hmm. I'm sorry. So this is a Google spreadsheet, which is very similar to MS Excel. If you are not familiar with that, you can edit it online. Then it's a like free source. You can just type Google Sheet and it will open. What like I have listed the various parameters over here that we have to find. So like two things we are already given: the timestamp, like it's a drive cycle that I was talking about. So it's just one standard FTP drive cycle, and if you click on the column at the right side, you can see how many seconds are there. So it's this drive cycle is of 765 seconds. Okay, then if you click on this column, you can see like speed is given in the kilometer per hour of speed, and what is the maximum speed. So here in this drive cycle, maximum speed is given as 96.3 kilometers per hour. So we have to convert it firstly into meter per second. Then we will find the acceleration, and based on that we will find all the forces which are acting on vehicle. Then total tractive force that we were talking about. Then from that we have wheel radius, so we'll find wheel torque, wheel speed. Then gear ratio we will decide one, and based on that we will find out which torque motor has to deliver and what will be the maximum speed of the motor, and based on that we will calculate which power of motor we will use. So this is how we will flow, and let's see if time allows us to make the whole calculation. So first of all, we have to find vehicle speed in meter per second. So what you have to do, just double click on the cell and press equal to key. Okay. And this particular cell, you have to, this particular given velocity, you have to convert it into meter per second. So convert any kilometer per hour value into meter per second value. Can you guys tell me the formula? What is that? How
into 5 by
into
5 by 18.
5 by 18. But how? Why 5 by 18?
1000 by 00.
Exactly.
1000 by
Like some people have
3600.
remembered it to be as 5 by 18, but they don't know exactly why we multiply by 5. And so it's actually 1000 by 3600. And when you simplify it, it becomes 5 by 18. So we will just keep it as 1000 by 3600. 3600 is 60 into 60. So it's R. So we divide, so we make R convert it into minutes, which is 60, and for each minute we convert it into seconds. So this is how it becomes 3600. So we have converted this value into meter per second value, and it's telling us to if we want to fill it automatically. So yes, we want to convert all the kilometer per hour value into meter per second value. So we will click yes, and we get all the meter per hour value into meter per second, kilometer per hour value into meter per second value. So this numbers does not seem good. So what we will do, we will make them up to 2 decimal places only. So now it seems good. Then we will calculate the acceleration. So acceleration is nothing but change in velocity per unit time. Okay, so initially acceleration will be 0 as vehicle is at rest, and at this point it's already 0. So from next point what we can do, change in velocity. So what velocity we have right now? So first we will enter a bracket. So no need to add bracket actually. This is the velocity minus this is the previous velocity. So this is the change in velocity that happened divided by the time it took to convert that into to achieve that velocity. So it will be always 1. This velocity minus this velocity, and time taken is 2 minus 1 second. So it's 1 second. So we can keep it as it is, and this will give us the acceleration at that particular instant. So it's asking us to if you want to fill it. So yes. So this is the acceleration at that particular instant. And then we will calculate the rolling resistance. So if you guys remember what is the formula for rolling resistance,
Gross
it was
vehicle weight into
yes, gross
coefficient of
vehicle weight into coefficient of rolling resistance, exactly. So gross vehicle weight is as I told you, summation of curb weight and the payload. So we have to find its summation. So we will pay equal to sign, then this cell plus this cell. So this is the gross vehicle weight that we get, and we will find the rolling resistance. So rolling resistance is, as you guys mentioned, it's equal to gross vehicle weight into the rolling resistance. So no matter what velocity you are at currently, it will be almost same at each velocity, because it does not depend on the velocity factor. There is no velocity factor in rolling resistance formula, so it will be constant throughout. So what we can do, we can have it written somewhere, and we can copy paste the same value over here. Okay, so here I will calculate the rolling resistance, and it's equal to gross vehicle weight into the coefficient of rolling resistance. So no, we don't want it to copy it over here. We will click here. So this is the rolling resistance we have in newtons. So what we will do, 17.17, we will 17.10. So we will copy this value for complete entire column. Control C, I pressed Control C. I came to the next column, then Control Shift and down arrow key. So it will take me to very bottom of the at bottom of the sheet. So I don't want it to till the bottom, but just till here. So what I can do, Shift. Okay, sorry. Or I can drag it till that particular value. Yes, so here it is. So it will be constant. Okay. Then comes the gradient resistance. So gradient resistance formula, you guys know, gross vehicle weight into gross vehicle weight into sine of inclination. Okay, inclination is like if we take 15 degree inclination, so that we have to calculate as 15 degree. So for now I am not putting any inclination part here for simplification. So we can consider gradient resistance as 0. Okay, and after that we will calculate the aerodynamic drag. So I hope you guys remember aerodynamic drag formula, which is firstly we'll calculate acceleration force. So acceleration force is nothing but mass into acceleration, right? So I pressed equal and mass. So this is the gross vehicle weight. Okay. Sorry, we haven't. I'm really sorry. In rolling resistance, we did not consider the acceleration due to gravity exactly, right? That also we need to consider. It's not mass into coefficient of rolling resistance. It's mass into weight into rolling resistance, weight into coefficient of rolling resistance. So we will consider that as well, 9.81. That will give us the exact value of rolling resistance. Okay, and this value we will put here. So I will show one more method to put that. Okay, I pressed equal to sign and I selected this column, and I if I press enter, this value is copied here, and if I drag it, so it will take the value of another column. Okay, and if I drag it down, so it will go to this column. Okay, as you can see. So we have to avoid changing the cell. What we can do, we can fix the value of this particular cell by adding the dollar sign here. Okay. So now if I have added dollar sign here, if I drag it over here, so it will take the value from the same cell each time. No matter how much I drag it, it will take the same value. So this is how you can make formulas for. So I will drag this for the entire column, and it will give us the total rolling resistance force. So keep in mind that it's not mass into the rolling resistance for coefficient of rolling resistance, but weight into coefficient of rolling resistance. Then gradient, we are considering it as 0 as of now. Then acceleration force. Acceleration force is mass into acceleration. So same thing we can do, as we have mass over here, and acceleration we have to take it from here. So, and acceleration will be changing, but mass will remain constant. So that thing we need to take care of again. So mass, so this is the mass, and I have to add the dollar sign that it fixes that particular cell, and into acceleration at that particular point. So this is how we will get the acceleration force. And I check yes. So you can see. So this will get calculated till where it has the value of acceleration. Okay. Then comes the aerodynamic force. So aerodynamic force, can you guys tell me the formula for that? I am equal to. So what was the first term in the formula?
Half rho v square
Half.
into
So half means it's 0.5 into rho. Rho is what? It's density of air. So density of air, it's here. It's taken as 1.125 kg per meter cube. So based on the air density in that particular region, you can take that. So in India, generally it's 1.125. Then half into rho into coefficient of aerodynamic drag, right? So here is the coefficient of aerodynamic drag into half rho coefficient aerodynamic drag
frontal
and
area.
frontal area, exactly. So that also we have to calculate, like based on width and height of the vehicle, you can find out that. And like in four wheelers, like in Tata Ace, it's like completely flat, somewhat flat from the front. So that's why you can take the exact frontal area or some percentage of that as effective. And when you have aerodynamic, then what was the next term? It was velocity square, right? So velocity in meter per second, it's square. So we can put that again. Yes, half. And these values are fixed, right? The air density. So we have to put the dollar sign here. Then the air density, then coefficient of aerodynamic drag. That value is also fixed. So I will add dollar sign here. Then its frontal area is also fixed, so I will also add dollar sign here. So this is how we will get the aerodynamic drag at each velocity instant. Okay, so let us make it up to 2 decimal places to look beautiful. Yes. So now we have calculated almost all the forces. Why we are leaving gradient force? Just take the gradient as 10 degree as of now, that it can climb 10 degree, and how it will be calculated is equal to weight, right? Weight is there, so sorry, not this one, this weight value, mass value, sorry, mass will be fixed value into 9.81, which is the acceleration due to gravity, into sine. Okay, so sine of this angle, and this is also a fixed value, so it will fix that and clear it. So is it taking in radians or something? So we have to provide the angle in radians. Okay, so 10 radians is a very huge angle. So what we will do, we will convert it in, this is degree, so we will convert it into radians, is equal to, how to convert degree value into radians value? What is the conversion? It's in radian terms, you get pi, right? So you have to,
Pi by 180.
yes, you have to keep pi in numerator. You can take the degree value into pi, which is 3.14 divided by 180. So this is how you will get the value in radians. And now in this sine value, you can put this radian, angle in radian, and we have to add dollar sign here so that it does not change the cell when we drag it. Okay. So this is how, but this will calculate for at every instant. So that's why I was not considering, because vehicle is not moving with it for all the velocity at all the time on that particular inclination. So that's why I was not putting over here, but just to show that, I just mentioned how to calculate it, and based on your customized drive cycle you can add it. Okay, so I am again making it 0, not to make the calculation very complex. Then we will calculate total tractive force. So it's the summation of all these four forces, right? We'll just write sum, and what all cells we want to sum, these four values, and close the bracket, press enter. So it will give sum of all the forces, and for each of the value it will be calculated. So this is what the force we are getting, total tractive force. Okay, and I guess time is limiting, so we cannot calculate all the things, but whatever we can, like up to motor power, I will try to calculate. Then how to calculate the wheel torque? Can you guys tell me the formula for wheel torque?
Force into wheel radius.
Force into wheel radius, exactly. So this is the total tractive force into wheel radius. So do we have wheel radius value? Yes, we have wheel radius as 0.27 meter. So how you can calculate is the value. So let me just put it here, and you don't have to measure it by scale or something. You can, a tire specification is given as in, like, it's a standard way of putting the tire specification from. So from tire specification you can calculate the wheel radius exactly. Then wheel speed. So wheel speed, for how you can calculate wheel speed, I already showed you the formula for that, right? V into 60 upon 2 pi into wheel radius. So it's velocity into 60 divided by, we'll put the denominator values in bracket, 2 into 3.14 into radius of the wheel. So this is the wheel radius, and as we have to fix this value, so we will put a dollar sign here, and this is how we have calculated the RPM of the wheel. So for at each velocity, what is the RPM of the wheel that we have found out. Okay, then gear ratio we have to calculate actually. So gear ratio, as we were talking in next last session actually, gear ratio is input RPM divided by output RPM, what we require at the wheels. So for getting the input RPM, we need to find motor RPM first. Okay, and motor torque, then we can decide the total gear ratio. So as of now, what we will consider, we will firstly consider random number as a gear ratio. Let's take it to be 5, and let's see what motor specs we get. Okay. So what happens when you have to decide the motor torque? Sorry, when you have to decide the exact gear ratio, you have to multiply the gear ratio in the differential gear and the each gear from like first gear, second gear, third gear, as such. So that's how you get the total gear ratio. And when you multiply torque at the wheel with the gear ratio, sorry, divide the torque at the gear with the gear ratio, so you get the motor torque. Okay, so we will calculate motor torque as wheel torque divided by divided by the gear ratio. Because torque gets multiplied, right? When motor is provided, if motor is having 50 Newton meter of torque, and at wheels, you can see we require what is the maximum torque required at the wheels. So maximum value you can see it's 717 Newton meters, and motor is capable of providing at the max 100 Newton meter of torque. So you have to multiply that torque. So if you are multiplying motor torque with gear ratio, you are getting torque at wheel. So from to go to wheel to motor, you have to divide that torque with the wheel torque. So this is how you get the motor torque. And motor speed, you have to, motor speed or RPM gets reduced when you attach gear. So speed will get multiplied by gear ratio so that we get the speed of the motor. So what we will do is equal to wheel speed into the gear ratio. So this is how we will get what RPM motor should run. If I select this particular column, so maximum RPM we require from motor is 4732 RPM, 4732 RPM. And now we will calculate the motor power. We have just like 2-3 minutes to complete the session. So motor power. So can you guys tell me what is the formula for power? If I have torque and I have RPM, what is the formula for power?
Sir, it's a 2 pi and T by 60.
Exactly. So
Torque
actually
into
it's
omega.
torque into omega. Yes, exactly. So when we talk about in terms of linear power, when there is a force in acting in a linear way, so it's force into velocity. And when we talk in terms of rotational motion, so force is analogous to torque, and velocity is analogous to angular velocity. So this is how we get torque into angular velocity, which is T into omega. And we all know what omega is. It's 2 pi n by 60 that we already have calculated. So what we will do in order to get motor power, we will calculate is equal to motor torque into motor RPM, right? But this is not sufficient. T into 2 pi nt. So we have n into 2 into 3.14 divided by 60. So this is how we will get the motor power, and not a checkbox. So what is the maximum motor power we require at peak? Our peak speed, maximum speed is 30,000. So it's in, sorry, we can calculate in kilowatt. So we have to divide it by 1000. Then we will get the value in kilowatt. Okay. And then control shift, take it down, enter. So now we have calculated in what happened 60 into, so it should give into kilowatt, right? Control C, then control shift down. Now it will give values into the kilowatt hour. Yes, so now you can see it's 30.9 kilowatts. So that's the maximum power we require at the wheel. So this is how you can see we have found the what to run the vehicle at these specs. Like this is the gross vehicle weight, and considering all these parameters, we can have a motor of 30 kilowatt hour of power, which can run our electric Tata Ace. So this is how you can calculate the motor power. And yes, for battery parameter calculation, we can have another session. So in 1 hour of session, we could cover this much only. And hope you guys learn the things from this. So if
So
you
what for power capacity?
sorry.
What for power capacity? How will we calculate that? If you just could tell.
Yes, what is the maximum power we require? So that you can see the maximum power we require is 30.9. So this is how you can see. Okay. So that much maximum power of motor you would require to have the vehicle running at maximum 96 kilometer per hour speed, which is there in this drive cycle. So you can accordingly modify this drive cycle for your specific requirement, or you can choose some other standard drive cycles. Okay. So let's come to the let's get a review of today's session, what we learned. So firstly, we found out what exactly, like why we are choosing Tata Ace to get electrified, and why multiple startups are working on like retrofitting of Tata Ace only. So that we saw. Then what are the steps of retrofitting that we learned. Then electric Tata Ace variants we saw from like North Way Motorsport, then Altair Green, then there is Trio, and all, like there are multiple startups who are working in this segment. And what approach we have to follow to design to size a powertrain. We saw two methods. Then we calculated the motor specs, and the we found out the various forces and motor specs. Okay. So yes, that was it for today's session. And if you guys have any question regarding this, you can mention. Or as you have learned this thing, so this is just a very small thing for now, because when you go for like calculating electric vehicle powertrain, there are multiple things. You have to consider the motor controller efficiency, then battery pack parameter calculation is also there, which is a backbone of electric vehicle. Without battery you cannot run. So that you have to calculate how many cells will be required, how many cells should be in parallel and series. That ratings we have to consider. So there are a lot many things to learn in electric vehicle domain. So what you guys can do, so like there are as I mentioned, there are various startups working on this, and lot many companies are there, like OEMs, and everybody every automotive company is moving towards the electrification. So you have, in order to get the good opportunity to be working in electric vehicle domain, being a mechanical or electrical engineer, you have to acquire various skills, right? And like these skills cannot be transferred with like small sessions, like 1 hour or 2 hour of sessions. You have to dedicate a lot of time to learn these things apart from your academics, and like along with your academics, if I'm not wrong. So what you can do, you can learn these things from, like there are free sources as well as, and like ETG is here to help you out to learn these things. So if you go to our website, Elite Techno Groups, you can see we are providing various industry-based online courses for you guys. So if you are enthusiastic about automotives and want to learn vehicle dynamics, so there is a course for vehicle dynamics as well. Then there is electric vehicle as well. So let's jump to electric vehicle domain. So currently there are 2 and 3 courses exactly, electric vehicle A to Z, which you can opt for 1 month internship, 2 month internship, and there is a whole nano degree program. So what exactly is the difference? Like in 1 month internship, you have limited content, and but you will learn something. Like there is a powertrain and vehicle sizing content you will also learn. And in 2 month internship, will also get hands-on battery thermal management and functional safety parameters. But in nano degree, if you go, you will learn various things from motor, electronics, and all such things. And there is a specialization program also we are coming up with. So this specialization program will give you a complete overview of each and every aspect of electric vehicle, where like from very basic to at very expert level, there are multiple things covered in very much detail, so that you can go through from our website. And there will be a promo code in the chat box and the form link. You have to fill that in order to get some discount when you enroll for ETG's program. Okay. So if you have any questions, you people can ask in the chat box. If someone from operation team can put the promo code and form link, it will be helpful.
Yes, hello?
Yes.
Yeah, I'll just send you the form link in a minute.
Sure. I will put. So hope you guys enjoyed this session and learn about various forces acting on vehicle, how to calculate them. And Excel is a very like easy tool to operate, and you can calculate so many things in an easy way. And there like other things as well that you can use as a uh, MATLAB or Simulink also, so that you get hands-on tools. MATLAB is a very popular tool in the industry, right? And if you learn MATLAB, it will open up more opportunities for you. So you have to learn MATLAB as well. And if you enroll in ETG's program, definitely you will be learning MATLAB. Okay, so I have put the form link, and promo code also I will put.
Yes, sir. I've
Yes.
shared the promo code, okay?
Yeah, sure. The promo code and the form link is available in the chat box. You guys can fill up and apply for the courses which are available there, and try to learn more things about electric vehicle domain. Okay. If there are no doubts and discussion points, we can conclude the session. And hope you guys have learned many things from this session. And if you want to like learn these things, you can regularly attend ETG's webinars, which we conduct in each week. Like every week, we come up with new topics and new informative content for you. So you can like keep checking our website. There is a webinar section, Elite Techno Groups. You can visit, and if you see the webinar section, you can see what are upcoming webinars are there. You can register for them, and yes, you can watch them for free. In case of any further assistance. Okay, so um, you can get add in our community. Like if you go to our website, there is a community thing. In you can get added in Telegram channel, and you can mention your queries and doubts over there, so that you can have interaction with us. And we are active on the Telegram group, so we will try to help you whatever assistance you require over there. So what I will do, I will put the Telegram channel link if possible, so you guys can join.
Sir, please a PPT send on ETG WhatsApp group.
TG WhatsApp group, PPT link you are asking about. So it's like you will be having the recording on YouTube. You can check on our channel, like on like previous webinars that we have conducted and upcoming webinars. So those will be there on our YouTube channel. You can get it. And instead of asking for PPT and sheets, you can try to do it by yourself, so it will make you more comfortable. Okay. Okay, then hope you guys enjoyed the session. Thank you very much for attending. And there are other webinars also lined up in upcoming week. So keep checking the website and register yourself. Just this 1 hour or 1.5 hour of sessions might add some values to your current knowledge and open up or broaden up your way of thinking. Like we are coming up with exciting topics. You can just check our website. Like there will be a next session on hyperloop technology from the aerodynamic point of view, then supersonic, subsonic kind of thing. Then in electric vehicle domain specifically, there will be next session about motors, electric motor technology. So like there is a one formula team who achieved the fastest acceleration record. They have broke that record of like in 0 to 100 seconds, they reached just in 1.51 seconds. So that kind of records can be made. So in order to learn these kind of things, how they achieved it, and or how electric motors have evolved from initial development stages, so that those all those things we'll be discussing in our next sessions. So keep attending these kind of sessions and regularly visit our website. Okay, so thank you so much everyone for connecting, for joining and being interactive during the session. I really appreciate your responses and the your patience to attend this session. Thank you very much. Keep learning, keep exploring.
Thank you, sir.
Bye.
Do we need to leave?